Hello, class. I hope you are all having a wonderful day or evening or morning whenever you are watching this. I hope that it is wonderful. This video is to show you where problems arise with Assignment 3. And so we'll just get right into it. So the very first question asks you to present a table. And anytime you're asked to present a table or a figure, you should go to our webpage, and under the Resources tab, we have a grading rubric and guidelines for projects and assignments. So here are the guidelines, and if we search for the word table, this talks about what all tables and figures need. Caption is very important. Caption is below pictures and graphs and are supposed to be above tables. And then we can scroll down here, and here's an example of a table. And as you all saw in your feedback, the table that we were requesting for this assignment should look like this. I understand this is not always the format that you see in every class, but it is the format that is used in all peer-reviewed publications, and it is considered a very neat and clean table format. Nonetheless, points were not marked off for incorrect formatting. They were marked off for having incorrect values for grasses, for shrubs, woody species, or for having incorrect values within the other cells, as well as for not having a caption. So you can't get full credit if you don't have a caption and if you don't have the correct values. So for future reference, make sure that your tables look like this, that your captions are in the appropriate location. And you can use the draw tool, which works really well in tables. You can just paint lines wherever you want them, and then you can get rid of them when you want to. Whoops. So I just clicked on that, and now I've got a line. Oh, I changed my mind. So I'm going to go no border, and I'm going to paint right back over it. Oh, let's get rid of that. So that's a simple way of formatting your tables. Now to show you how to do the calculations. So again, a lot of people really missed these values here. So I want to show you all how to do them. And some of you didn't even fill it out at all. So keep in mind that to read the instructions thoroughly, and I understand there are a lot of instructions. This is an online class, and if we did have in-class sessions, it would be a lot easier, but we don't, and so a lot of the onus is on you to make sure that you read everything, as much as I'd love to read it for you. But as it says here, make sure that it includes all of the same data that's in the Excel spreadsheet. So that's why those columns are there. So you were supposed to actually fill out those columns. And keep in mind that if something is present in plot size 1 for a nested frequency, which is what we did here, nested frequency, if it is present in plot size 1, then it is present in all of the plot sizes greater. If it's present in plot size 2, then it's also present in plot size 3 and 4. But it's not present in plot size 1, because we're writing down, when we were doing this, we're writing down the smallest plot size that we see it in. So let's go to transect 1, and if we're trying to figure out the frequency of grasses in the different plot sizes, in transect 1, plot 1, a grass was present, so we're going to put a 1 there. A grass was present in plot size 1. In plot 2, no grasses were present in transect 1. Plot 3, a grass was present in plot size 1. And this is all very straightforward, so I'm just transferring the lowest value up top here We'll go to one that's a little more tricky, maybe over here. It was present in, so this grass sedge was present in plot size 2, this grass was present in plot size 3, and this grass was present in plot size 4. But if we're just calculating the frequency of grasses, we again, just like the technique in the field, you write down the plot size of the smallest frame for the nested frequency. So if it was in plot size 2, if a grass was present in plot size 2, then it can be deduced that it was also present in 3 or 4. I know I'm repeating myself. I just want to make sure that you guys understand. It is a bit complicated, but hey, that's why we're learning it. All right, so so I filled these out and I did it by hand. There's probably a command that you could use, count the smallest number or something like that command. I did not. Okay, so now we want to calculate the frequency. So I'll just explain what's going on here. So we started with the COUNTIF command, which most of you guys used for your frequency calculations, and it was what was suggested in the assignment as well as the instructional video. So COUNTIF, and then we highlight D7 through BU7, which is all of our grass data. Count if any of those values are less than or equal to 1. So we didn't put a 0 in these, so it's not going to count the ones that are zeros, which is good, because otherwise it would count them. So less than or equal to 1, and we had 27 hits. And again, you just take that and divide it by 70. A frequency value can't actually be greater than 100% because there's only 70 plots. And so therefore you can't have more than 70. So we did the same for 2, 3, 4, and I'll go ahead and do 4 since it's a little bit difficult. Oh, and it's not done yet. I work out of a few different. So first we're going to start with, again, with the equal sign, COUNTIF. We're going to highlight all of the data that we want to count all the way down to plot 1, transect 1. COUNTIF that, and then it says range, comma, criteria, and you put little quotations around. If that is less than or equal to 4. And there we go. Oh, good, I counted them properly. So 66. So that means that a grass was hit in all of these transects 66 out of 70 of the times. And so again, like if it's in transect 1, it's also in 2, 3, and 4. Or if it's in plot size 1, then it's also in 2, 3, and 4. I hope that clarifies things. Please let us know if you have any questions regarding this. All right, so back to the assignment, and then of course you fill it in front. All right. So the next part where a lot of people lost points, in general, so we were only asking for each of the species listed below. Some of you did all of the species, and therefore the substance was lacking for each individual species because there was so much breadth that there was very little depth on the species of particular interest, which were these 3. For the data visualization, so you were asked to do all 3 of these things for each of these 3 species. Ideally, you would do data visualization, you would do it in order. Data visualization results in conclusion for Idaho fescue, data visualization results conclusion for Medusa head, etc. But if you didn't, that wasn't, there were no points marked off for that. It just definitely makes grading and comprehending much easier if it's organized in that way. So each was worth 25 points. And for the data visualization, and I think this is going to be in every assignment, make sure you review the rubric and the guidelines. So when you make a graph, you have to make sure that you have a caption. You have to make sure that your axes are appropriately labeled and that you have units. And also that you can read the axes. Some of you had axes that were cut off, and I'm not sure if that's formatting from copying and pasting it into your assignment, but some techniques to get around that would be to paste it as an image to make sure that you don't lose your axes. So if you lost points here, it was probably because you didn't have a caption, you didn't have appropriately labeled axes, or it was a mess in that the axes were not legible, or you didn't have units. Results were pretty straightforward. Most of you did a really good job. One of the things you want to do is refer to the actual data, the plot size, and then, you know, refer to the percent change. So if it dropped from no, that's wrong. Wow. Whoops. If it dropped from 82%, or it went up from 82% to 90%, you'd say there was an 8% increase. And I just realized that the data that you guys were given was not calculated properly from 1998. Which in turn explains why people did not get the correct values. And so I will be adding points to everyone's assignment who got points marked off for incorrect values. And I apologize for that. But anyway, this is the correct way of doing it, and that is a residual from years past that was not fixed. And I apologize for that. Okay, back to the assignment. For the conclusion and discussion, the main point here is that you connect the results with the conclusion. So Medusa had reduced in frequency. Let's say Medusa had reduced in frequency from 50% to 20% or something like that. We would say in a sagebrush community, the implications are that this is a good thing because Medusa head tends to take over, form monocultures, and displace native species. So something like that, making sure to cite it, saying that on this trajectory it's looking like, you know, the ecosystem itself is improving, and then find some citations. Just make sure that you're making a connection with what's actually happening in the community. A lot of you wrote facts about Medusa head. Medusa head's an invasive species. In general, it blah, 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 but didn't actually relate that back to what it means in the community and what it means in reference to your results. So it's decreasing. That actually means something different in the community. Okay, and then also please review APA format for citations. You need to have in-text citations, and yeah. On the guidelines for projects and assignments, there is an example of a conclusion here. Talks about what the results meant, the implications of the findings, and then here is an appropriate format for an in-text citation. You put the author's last name and the year. So that is the way that it's supposed to be done. Of course, we do have some citations that you can gather from the assignment and the assigned readings in SoftChalk. Okay, hope you have a wonderful day. You'll be happy to see your new points added.